Now we're moving on to the last section in Chapter 17, at Section 8, and it's going to be quadratic optimization. And what we're going to just focus on here is our maximum value or our minimum value. All right, so now we're going to be solving real-world examples. We're only doing one question for this video. So although the last couple of videos have been a little bit longer, 12 minutes and 18 minutes, this one should be pretty short. So remember, we can tell if a graph is facing up, if our A is greater than 0 positive, or if it's facing down, if our A is less than 0 negative. When our A is positive, we have a minimum value at our vertex, the y value of our vertex. And when we have a negative value of A, we have a maximum value at our y value of our vertex. And the process of finding the maximum or minimum value of a function is called optimization. And optimization is a very useful tool when looking at such issues as maximizing profits, minimizing costs, and maximizing the heights reached. So this is something that you would actually use in a real-world example if you're solving or doing certain problems in business or throwing an object or something along those lines. But this is something that you actually could use. So we're going to do just one example, and that is it for this section. All right, so it's the height h meters of a rocket t seconds after it is fired vertically upwards is given by h of t is equal to 100t minus 5t squared, where t has to be greater than or equal to 0, which makes sense. T cannot be negative, or otherwise it means we're traveling back in time because t is seconds. So whenever you see this, it means that we're restricting our domain. I know we're not really getting into that, but this is telling us we're restricting our domain, so we're only looking at the positive values of t. If t is ever negative, we can't use it because it has to be greater than or equal to 0. So if we solve for t and it says it's equal to a negative value, then it's an answer that you cannot use. All right, so it says how long does it take for the rocket to reach its maximum height? So since in front of our t squared it's negative, that means that this graph is facing downwards. So our t is our seconds. So when it says how long does it take to reach its maximum height, that is our x value or the h of our vertex. So we need to go ahead and solve for the vertex. And to solve for the vertex, so for the h value of it, in order for us to see how long does it take to reach its maximum height, we know that x is equal to negative b over top of 2a. In this case, our a is the number in front of the x squared, so it's negative 5, and our b is the number in front of the x, or the t in this case, and that is 100. So our x is then equal to negative 100 over top of 2 times negative 5. So when we plug this in, we will get negative 100 over top of negative 10. So that, negative 10. So that means our x value of our vertex is 10, or it takes 10 seconds in order for our rocket to reach its maximum height. So 10 seconds. Then for B, it says, what is the maximum height reached by the rocket? So we know once we solve for the x value of our vertex, which we know is 10, if we want to solve for the y value of our vertex, which tells us our maximum or our minimum, and since this is facing down, this is giving us our maximum value, we go ahead and substitute it in. So our h of 10 is equal to 100 times 10 minus 5 times 10 squared. So now we just go ahead and solve. Our h of 10 is equal to 1,000 minus 10 squared is 100 times negative 5 is minus 500. So our h, our height after 10 seconds is equal to 500 meters. So our answer for B is 500 meters. And that means our vertex is at 10, 500. And this tells us how long it took to get to our maximum value. And this is our maximum value since it's facing down. And then it says, how long does it take for the rocket to fall back onto Earth? Well, when our rocket falls back onto Earth, that is when our height will be 0 because we will be at the ground. So that means that we need to set our h of t equal to 0. So I'm going to go ahead and solve this underneath here. So we will get 0 is equal to 100 times t minus 5t squared. So we can go ahead and factor this out. We can say factor out a negative 5. So negative 5 is equal to, we can factor out a negative 5t. So negative 5t times, so when we factor out a negative 5t, we're left with t. And when we factor out a negative 5t out of here, we're left with minus 20t is equal to 0. And we can set each factor equal to 0. So negative 5t is equal to 0, or t minus, this should not be 20t, but it should just be minus 20. or t minus 20 is equal to 0. So when we divide by -5, t is equal to 0, or when we add over 20, t is equal to 20 seconds. So it says, how long does it take for the rocket to fall back to Earth? So although a rocket is on Earth at 0 seconds, that means that we haven't shot it yet. So it's not falling back to Earth. So we would not say 0 as part of our answer because we have not shot a rocket in the air yet. So in this case, only the positive 20 will be our answer. So for C, how long does it take for the rocket to fall back to Earth? And that will be 20 seconds. All right, that is it for this video. I know it's kind of quick, and I know, but we have been using this already for a few sections now, so that's why I thought we can go through it a little bit quicker and only do one problem. We can go over some questions that you have in class, or just message me on Remind. All right, that is it for this video, though.